Alright, so our three types of questions here. We've got our vanilla kind of plug and play question where we just put in the formula. We've got a composite solid, and we've got a working backwards kind of question. So let's see how we approach these all differently. The plug and play ones are really generally quite straightforward, right? Because we've got some shape that we want to find, in this case the volume of, and we just need to go back to our formulas and see what values we're given and then put them in. In this case, I want to find the volume of a cone, so that's going to be 1 over 3 pi r squared h, where r is a radius of the base and h is the height there. Let's chuck that in. Pi times 80 squared times 75. I might need my calculator for this one. And we get a big number here, 502,654.82. Is that all? Oh, I need to remember my units, right? So I'm working with volume, so that's going to be cubic. So in this case, it would be cubic millimeters. Okay. In this case, I've rounded to 2 decimal places. Cool. That's plug and play, vanilla kind of question. So how they can make these questions a little trickier is that they can start to introduce composite solids. So that's when you start merging the solids together and forming new ones, right? And in this case, we're something that looks a bit like an ice cream cone, and we're asked to find the surface area. Just being careful here, right? Before I even start jumping into it, I just want to see what shapes I have. So I can see there's a cone there, and I can see that on the top, I've got half a sphere, so a hemisphere. Now I want to think about the surface area formulas for here. The surface area of a cone, that's going to be pi r squared plus pi r l, and then the surface area of a sphere, well, the surface area of a sphere is 4 times pi r squared, but because I'm looking for a hemisphere, I just want half that. So that should be 2 pi r squared, right? But one really common mistake with these composite solids is either not finding all the surface areas or finding too many. And this is where it's really important to be familiar with the formulas, how they actually work. The surface area of a cone, well, that's pi r squared plus pi r l. Pi r squared is that circle component, whereas pi r l is that curved surface of the cone. So when I'm doing this, I want to think, oh, actually, the surface is only the exposed parts of that circle. I don't actually want that there. I'm not going to include that when I'm calculating. The only things I need actually are the hemisphere and also just this part of my cone formula. So that's how I want to think about these questions before I jump straight into substituting the formulas. Just got to be careful there. Now that I know what my formulas I'm going to use are, I want to think about, okay, how can I find the missing values? At the moment I only have these perpendicular heights. What you might notice is to find really some information about this sphere, I've got this length is 10, and this length here is 15. So this leftover length, that must be 5 centimeters. Since I know that's 5 centimeters there, since it's a hemisphere, that's actually coming out from the center of the sphere. So that 5 there, that represents the radius. So now I know that my radius is 5. But it's not only this length which is 5, because if 5 goes all the way around the whole sphere, that length there is also 5. And that's actually going to help me find the slant height, because the slant height is this length here. Right? I'm trying to find this length. And this guy, this is the perpendicular height, right? I'm going to drop a line down there, that might make it a bit clearer. That would just be 10. So I want to think, how can I find the slant height here now? Right, yeah, I've got a lot of information, and if you think back to your year 8 maths, I can actually use Pythagoras' theorem here to find the slant height. So just using my Pythagoras, that would be L squared equals to 10 squared plus 5 squared, because I've got a right angle triangle here. So L would equal to the square root of 125, if you sum these up. And then just substitute your formula, right? The total would be equal to pi times r times L, so pi times the radius, 5, times the square root of 125, plus 2 times pi r squared. 2 times pi times 5 squared. Put that in. You're going to get 332, and I'll round it to 2 decimal places, 70. And thinking about my units again, so surface area, I'm dealing with space, so I'm going to use those squared units, so square centimeters. That's the surface area of a composite solid. Last example. Okay, so a pyramid has a volume of 32 square centimeters, a side length of 4 meters, so 32 square meters, and a side length of 4 meters. Find its perpendicular height. Okay, what I'm really trying to find is this one. And this is a working backwards kind of question, right? Because they've given you the volume, and they've given you the side length, but they want you to find a different aspect of it. They want you to find the perpendicular height. When I'm looking at these, I want to go back to the formula. I know that the formula of a pyramid is 1/3 AH. And it's kind of like filling in the missing pieces of a jigsaw puzzle, because you have the volume, you have the side length, but you need to try and find the perpendicular height. So, before I do, I know that the volume is going to be 32. How do I find A? So A, remember, is the area of that base there. Well, if this is just a square pyramid, the area of the base would just be equal to 4 times 4. That's just 16 square meters. And so let's put in our information. I know that the volume is 32. I know that the area is 16. And I'm trying to find that perpendicular height there. How can I go from this and rearrange into the h's by itself? Well, why don't I just simplify this out a little bit first? So this would just be 16 on 3 times h. And then you always want to think about opposite operations when you're trying to rearrange expressions, right? Here's multiplication. What's the opposite of multiplication? Yeah, that's right, it's just division, right? So divide both sides by this fraction. And even though it's a fraction, I can still do that. I can still type that in my calculator. 32 divided by 16 on 3. That will equal to h. And you put that in, you should get 6 units. So that perpendicular height there is 6. And I know that's right. So to always check, I can put it back into this original expression. If I put in 1/3 times 16 times 6, which is these values here, I should get 32. So going back to the original formula is always a really good way of checking that your answers are